Hi and welcome back. So in the last video we had done the electron configuration for mercury, and mercury was it was a D block element. So our last entry in our configuration was in the D subshell. And so in this video, what we're going to do is we're going to do the electron configuration for lead. And the important thing that I guess I'm trying to show you in these videos is how we're going to fill up these F shell electrons. And that's really the important thing to realize about the F shell, is how to deal with these elements that are in either the P block or the D block that are going to have these F subshell electrons in them. So anyway, I'm going to clear off my drawing and write down lead. So we are looking at PB, and just write down my periods: 3, 4, 5, 6, 7. And so let's start off with our electron configuration. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So we're at 3d10. We've got zinc here, and then we go to 4p6, 5s2. Now we're on 4d, 4d10. So that gives us something like cadmium, and now we fill up 5p6. That is the same electron configuration as xenon, and this is lead down here. I'll circle that. So now we have the electron configuration of xenon. So now we move on to our 6s shell. I'll just arbitrarily change colors. So now we have 6s2, and so now we're at the point where we're going to start filling in our F shell, because we are right here. We're right here at this point. So we have to fill our F, I'll call this the F block. So we have to fill in our F block orbitals, or our F orbitals. And we know that when we fill in the F orbitals, that just the same way we backfilled in the D block, we backfilled one. This is the period number. We're going to backfill 2 period numbers. So we're in the 6th period, so this would actually be 4F14. And we know that it's completely full. We have a completely full F group of orbitals, F subshell. So that means that we have got 14 electrons, because we've got 7 orbitals in the F collection of orbitals. 2 electrons per orbital gives us 14 electrons can go into the F orbitals. So we have that completely filled up. And now, after we completely fill that up, we move on to our D block. And we're in the 6th period right now, so we're cutting across right here. So we're in the 6th period, which means that we are going to be filling up 5D. And how many electrons are in our 5D orbital? We're going to have 10 of them, right? And so now, the very last thing we have to do, and remember this makes sense because lead is in the P block, and our last entry is going to be the period that we're on. So we're on period 6, P, and how many electrons are going to be in the P in our 6p orbitals for lead? Well, we're going to have 2 of them, right? Because we're in the column. The column that starts with boron is going to have whatever number we're on, P1. The next column will have P2, P3, P4, P5, P6. So lead is in the P2 column. So our last entry is 6P2. And let's just go ahead and add up the electrons and just make sure we did this right. So we have 2 plus 2 plus 6 is 10. 2 plus 2 plus 6 is 20. Plus 10 is 30. Plus another 10 is 40. Plus 6 plus 2 is 48. Plus 6 is 54. Plus 2 is 56. Plus 14 is 70. Plus 10 is 80. Plus 2 is 82. And that is lead's atomic number is 82, so we have 82 protons, which means in our neutral atom, we also have 82 electrons. So this would be, excuse me, this would be the electron configuration for lead. I'm actually going to end this video right here. Hopefully now, actually, you know what? Let's do one more example before I end this video. I'm going to clear off those drawings, label my periods again. 1, 2, 3, 4, 5, 6, 7, and let's do something I actually know the name of. I guess there's not. Oh, I guess we could do. I guess there's not going to be too much I know the name of. Let's do this. I should have printed this periodic table a bit larger so I could actually see what these names are. Is that Hassium? I'm not even going to try. Sorry. So anyway, let's try to figure out the electron configuration for Hassium. So HS. And so let's start off. We're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So we're right here, we're at calcium. So now we go 3d10, 4p6, 5s2. So we're now at 5s2, we're at strontium. So now we fill in 4d10. 4d10 gets us to cadmium. So now we fill in 5p6. That gets us to xenon. Now 6s2. That gets us to barium. So now what do we have to fill in? Well, we're on our first f orbitals, right? We're right here on our first f orbitals. And how many electrons fit in there? 14, right? And we backfill these two periods. So we're going to say that this goes into our 4f14 orbitals. And now, and so after we fill up 4f14, we're going to fill up 5. So we've just filled up right here. So now we have to fill up all of these orbitals across our d block. So we're going to fill up 5d10. So we've gotten to that point. Now we have to fill up all the way across our p block. We're in the 6th period, so we say 6p6. Now we're on the 7. We're on the 7s orbitals, so we're going to fill up 7s2. And now we're right here. We're on our second period of our f block, so we have to fill up all of these orbitals, all of our f orbitals here. So, and again, we're backfilling 2 periods. So this is going to be 5f14. And then the last thing we have to do, the last orbital that we have to fill, or the orbitals that we have to fill, is we have to fill 1, 2, 3, 4, 5, 6 electrons into our 6d orbital. So we're going to have 6d6, and that's our last entry. And now to check all of this, let's start adding up. So we've got 2 plus 2 plus 6 is 10, plus 2 plus 2 plus 6 is 20, 30, 40, 48, 54, 56, 70, 80, 86, 88, so 88, that would be 98, and then that would give us 102 after 5f14, so we've got 102 plus 6, that's going to give us 108, and that's what we want. That's how many electrons we're looking for. So we have got 108 electrons in this configuration. Hopefully this makes sense. Again, you know, the important things for you to realize is how we fill up these 5f14 orbitals. In the next video, I'm going to actually start talking about some individual cases of what electrons would be for elements inside the f block. And again, I'm not incredibly qualified, so we're actually probably just going to look at Wikipedia entries that essentially tell us what the electron configurations are, and we'll see that there are going to be a lot of exceptions to any rule that we could really come up with for elements that are in our F block. But essentially, the big thing to realize, or the big thing that you should be able to do after this, is you should be able to fill in the electron configurations for elements in the P block and also in the D block that are going to have F shell orbitals as part of the electron configuration. So hopefully that's you're finding this useful. And actually, you know what? I'm going to erase my drawing one more time and just say that hopefully let's just draw our line to figure out where all of the electrons, at this point, really above that line, you should be able to figure out any electron configuration so far, including the exceptions that we've covered. And the only exceptions that we have above this line are chromium and copper. So hopefully you're understanding this. Please leave comments if you're not, and I'll try to maybe post some more clarifications. Anyway, in the next video, we're going to start talking more about actual configurations for electrons in our F block. So anyway, I will see you in a future video. Thanks so much for watching.